right, so we're looking at an introduction into our limits of sequences, and this is just our definition here of our limit. So basically what we're looking at now is as we plug our n's into our general term, it's going to give us our sequence of numbers. And we want to see, is that sequence approaching something, some value L, some limit. And so if it does, we say it converges, and if it doesn't, we say it diverges. So it's like this. I've got this little general term going on here. So if I plug in 1, my first term would be 3. I plug in 2, my second term is 1.47. 3, it's 0.72. Let me zoom in a bit so you can see this. And then 4, don't like it when it does that, but there we go. All right, 4 is 0.353, and then again, as we keep moving these, so as my n's get plugged in, you can see that we are approaching something. Our general term here is approaching 0. So as our n goes off to infinity, our general term is approaching 0. And that's what we're looking for. So it works just like before. Our limits from before are exactly the same as what we're going to be doing here. So same rules, same tricks. I'm going to introduce a few more as we go through the videos. But we basically have two situations. Our limit, you can see here, our general term is coming up, and it's actually approaching it very, very nicely. And then we have here, it's coming up and then down and then up and then down. But from the top and from the bottom, they're both approaching the same value. So we are going to get a limit. So these are two convergent situations. All right, so let's just try one, just so you can kind of feel a little more relaxed when you do this. So we've seen rational expressions before. So we're going to be doing the limit as n approaches infinity of our a sub n, and we want to see what it becomes. So this becomes the limit as n approaches infinity And so we handle these limits just like we did before. So if our function has a limit and f sub n is a sub n, then that means our a sub n also has a limit. So basically, all we have to do here is just take our limit. So we always divide by whatever the denominator's n square n is. So this would be the limit as n approaches infinity of 3 over n squared plus 5n squared over n squared, n over n squared plus n squared over n squared. And then we reduce. So that becomes 1. Those cancel and gives us 5. And then everything else is left as a fraction. So we have the limit as n approaches infinity of 3 over n squared plus 5 over 1 over n plus 1. And then if you remember our rules, this is going to go to 0. This is going to go to 0. So we end up with a limit of 5. So as n approaches infinity, our sequence is going to go towards 5. That's it. So let's try another one. So we have the limit here as n approaches infinity of a sub n is equal to the limit as n approaches infinity of 3 plus 5n cubed. So you can see all I've done here is change it to n cubed. And if you remember with our rationals, when their top is bigger than the bottom, we get our slant asymptote. So that's what this is going to be giving us, something different. So then it's 3 over n squared plus 5n cubed over n squared. Remember, we always use the bottom. All right, so now we have the limit as n approaches infinity of 3 over n squared plus 5n. And then this is 1 over n plus 1. And we apply it again. So anything that has our fraction with our n going towards infinity, we're going to get 0. And so this equals now the limit as n approaches infinity, because we still have an n left. And if you notice here now, it's just 5n. Well, if we were to plug infinity in there, you know it would go off to infinity. So this is an example of convergent. It converges, and this is a divergent. So the first one is a convergent sequence. The second one is a divergent sequence. So that's what they're talking about when they state this little limit of sequences. So a sequence a sub n has the limit L, and we write this. If we can make the terms a sub n as close to L as we like by taking n sufficiently large. So that's what I'm doing here. So as I keep going and making my n larger and larger, are we getting some general term that is approaching L? And if it is, it's convergent. If it isn't, it's divergent. So on the second one, it's going to go off to infinity, which means it's just going to diverge. We're not going to be approaching some number. There you go.